So we were able to compute the measure of variation. As I say, I advise you to use Excel or your calculator, because there will be no time for you to do all this computation manually. So if you have trouble using your calculator or Excel, one of the two, let me know so that we go over it again. So you can practice during your homework, you can practice also all over the tech homework. The standard deviation is a measure of variation. It is used to determine how the variables, the distribution actually varies. But sometimes we may have to deal with two distributions that are not of the same nature. For example, if a distribution is given in tens, another distribution is given in hundreds or thousands, you may not just compare their standard deviation to feel like one varies more than the other. We will learn about the coefficient of variation, which is used to compare two variations, two distributions. So the coefficient of variation is the standard deviation divided by the mean times 100%. For example, let's look at this example. The trading post on Grand Mesa is a small family-run store in a remote part of Colorado. The Grand Mesa region contains many good fishing lakes, so the trading post sells spinners, a type of fishing lure. The store has a limited selection of spinners. In fact, the trading post has only 8 different types of spinners for sale. The prices are, we have these prices. Since the trading post has only 8 different kinds of spinners for sale, we consider the 8 data values to be the population. This is just for us to use it as an example. So we are going to find the mean and the standard deviation. Can you use either your calculator or Excel to do that? Just 1 minute. Yeah, you can take the, use your calculator. I don't need to do it. My laptop sometimes trouble. As I'm using Zoom, it is a little bit difficult for me to manipulate the Excel as I was doing, but if need be, I will do, because I want to assume that everybody can do that for now. So enter the 8 values, either in your calculator or Excel. You are going to have one of the two that you feel more comfortable using. I'll always be using that one unless I direct you to use another one. What I encourage you to use for this class is your calculator, but sometimes we are also going to learn how to use Excel, because sometimes Excel can do things that your calculator cannot do. And sometimes we want to report results. For example, for your project, I advise you to use Excel because you can copy and paste easily. For your exam, certain things you would use Excel, because if you use your calculator, you cannot copy a graph from your calculator to give to you. So we have the mean here is 2.14, and the standard deviation is 0.22. We are using it as the population. So the coefficient of variation will be mean over, standard deviation divided by mean times 100%, which is 0.22 over 2.14. If you are using your calculator, you will see two standard deviations, S and sigma. S is for the sample, sigma is for the population from your calculator. For those who are using Excel, you will only have the answer for sample. When you see your answer not the same as the one you have, just ask the question, because I might not remember all of these details. So anything you feel like a little inconsistent, just ask, I will explain, and we will learn more. So we have a coefficient of variation of 10.28%. Yes. If you feel like you don't know how to use your calculator Excel, just be asking me. We will need it. For now, we are actually playing with it. But there will be time that we will actually need it more. So all of this stats, everybody should be able to know. How to enter data value, we should be able to know. So when you don't know, just ask. I will tell you, and gradually you are going to get used to. I always give the example of the cell phone. Most of the time you have a new cell phone, you feel like I can never use this. After 2-3 days, you feel like you know it. So it's by practicing using calculator, at a point you will feel like, why did I think this was so difficult? I mean it, it's not like just talking. That's how it is with technology. The Chebyshev theorem. Generally, we consider the standard deviation as the unit of measurement of any distribution. So we consider the mean to be at the center. The mean is the middle, the center, the average. And from it, we can position any score. But scores that are very important or that are generally thought of are the integral units from the mean. For example, we can have here x bar plus s. X bar plus 2s. X bar plus 3s. That means that this distance is s. From here to here is s. From here to here is s. So we consider s as our unit. It could be sigma as well. The standard deviation is the unit. And to the left, x bar minus s. X bar minus 2s. X bar minus 3s, and so on. So an important portion in statistics is to know what proportion of values are within, one standard deviation. These values are those that are one standard deviation away, either to the left or the right, or less than one standard deviation. When we say you are within 5 minutes from campus, it means you could be 1, 2, 3, up to 5. It's not exactly 5. So when we say we are within one standard deviation, it means we are in this range of values. When we say we are within one standard deviation, if we are within 2 standard deviation, that means we've moved 2 standard deviation to the left and 2 standard deviation to the right. So this is within 2 standard deviation. So the range of values that are within K standard deviation, range of values within K standard deviation is mean. It could be mu instead of x bar. I'm not always going to be putting both. If it is population instead of x bar, we will use mu. But so far we will be using more of sample. So x bar minus ks, this is less than or equals to any score x, less than or equals to x bar. So these are values that are within K standard deviation from the mean. So this is 1. Here is 2, from here to here. From here to here is 3. So values that are within 1 standard deviation are also within 2. Values that are within 2 are also within 3. So the question that Chebyshev is trying to answer in his theorem is the minimum proportion of values that will be within K standard deviation from the mean, where K can be any number bigger than 1. So Chebyshev will tell us that at least 1 minus 1 over K squared, at least 1 minus 1 over K squared, the minimum proportion of values that are within K standard deviation from the mean is at least 1 minus 1 over K squared. That is what you read here. For any set of data and for any constant K greater than 1, the proportion of the data that must lie within K standard deviation on either side of the mean is at least 1 minus 1 over K squared. So what you want to remember here is the number of standard deviation, the minimum size. Given the number of standard deviation, Chebyshev gives you the minimum proportion, 1 minus 1 over K squared. I usually give you some standard computations. So within 2 standard deviation, we could do 1.5, 1.1, provided K is greater than 1. But because we like integers, we are only doing for integers here because it's easier to compute. For example, if K equals to 2, 1 minus 1 over K squared, K equals to 2, K squared will be what? 4, which is 3 over 4. That is at least 75% of values are within 2 standard deviation from the mean, whatever distribution you have. So if we go to 3, we are going to have, if K equals to 3, then K squared equals to 9. 1 minus 1 over 9, which is 9 minus 1 over 9. 8 over 9. If you use your calculator, you will have 8 over 9 is 88.88. We'll just write 88.89. At least 88.9. Okay, 88.9 of the data falls in the interval mu minus 3 sigma or x bar minus 3 sigma So within 3 standard deviation, we have at least 88.9% of values. Let's look at this example. I think either in your take-home problem or your project, I will give you data values and I ask you what proportion of values are within 2 standard deviations. Before we do this example, I want us to just look at any data here. Look at these data values. Anybody remember what the mean was? 2.14. And the standard deviation?
0.22.
So can you subtract the standard deviation from the mean here? 2.14 minus 0.22. 1.92. So this is 1 standard deviation. Add 2.14 to 0.22. So these are the values that are within 1 standard deviation from the mean. Chebyshev does not consider 1 because 1 square is 1. 1 minus 1 is 0. So if you want to follow Chebyshev, you will say at least 0% of values are within 1 standard deviation. Is that any useful information? We should have at least some values, right? So that's why 1 is not considered, but you must be greater than 1. So now, just for the purpose of understanding the meaning of the theorem, how many values are within 1 standard deviation from the mean? And we try to count. Look at these numbers. How many values are within 1 standard deviation? Yes. 6. Is it 6? Do you see, everybody see that it's 6? We just want to take each value and know if it is bigger than 1.92, if it is less than 2.36. So we have 6. So how many values are here in total? 8. 6 over 8 is 3 over 4, which is 75%. So 75% of values are within 1 standard deviation from the mean. Chebyshev did not tell us anything about 1 standard deviation. Okay? It starts with bigger than 1. But I just want us to know what is the meaning of an interval in terms of Chebyshev. So now, for k equals to 2, we are going to do 2 times sigma, which is 0.44. This is the range of values for within 2 standard deviation, as we put there. So you will do 2.14 minus 0.44 for 2. Do we all understand what I mean here? For k equals to 2, you multiply the standard deviation by 2 and subtract it from the mean. What do we get? 2.14 minus 0.44. You can use your calculator to check that. 1.7. And 2.14 plus 0.44? 2.58. How many values are here? There were only 2 left. How many? 7. What is 7 divided by 8? 0.88. So what proportion of values are within 2 standard deviation from the mean here? 88% of values are within 2 standard deviation from the mean. Do we understand this? Is it consistent with the Chebyshev theorem? Is it consistent with the Chebyshev theorem? We just want to think a little bit. The Chebyshev theorem tells us that what? At least 75% of values are within 2 standard deviation from the mean. Is this information consistent? Yes, it is. And it should be, because in mathematics, when we say theorem, it means that it is true. Okay? So if you feel it's inconsistent, maybe you did not understand the theorem very well. The theorem tells us that within k standard deviation, there is at least 1 minus 1 over k squared. So if we find 100%, it remains consistent with the Chebyshev theorem. So several questions could be asked. Here we can ask, what is the minimum proportion? We could also ask, what is k, so that at least 88% of value or 80% of values are within k standard deviation from the mean? That's the next type of question. Nope. So look at this question. A survey of local companies found that the mean amount of travel allowance for executives was 0.25 cents per mile. That was a long time ago. The standard deviation was 0.02. Using Chebyshev theorem, find a minimum percentage of data values that will fall within 20 cents, $0.2. We'll do some mathematics here. So look at what will happen here. We say we want to find the minimum percentage. That minimum percentage, according to Chebyshev, is 1 over k squared. Is that so? That's the minimum proportion, 1 minus 1 over k squared. So if we know k, then we can answer this question. So we want k so that x is between 0.2 and 0.3. And the Chebyshev interval is in the form x bar minus 2s, x bar plus. What is s here? From this example, what is s? If you want to understand, just read and check and tell me what s is. What is the value for s? 0.02. Even if you don't want to answer, just think about your own answer. When somebody says it, and if it is not what you have, you may ask, why is it? That is how your brain will be learning. So S is 0.2. I'm sorry, 0.02. Because we say the standard deviation was 0.02. That's what is our S. I'm sorry for this. Look at what I wrote here. It's not 2, it's K. We are looking for K. Please change here. We are looking for this K. So, and what is the mean? $0.25. So we have here that 0.25 minus 0.02 times k is less than or equal to x less than or equal to 0.25 plus 0.02 k. I just wrote this one down, replacing x bar by its value and s by its value. So to find k, just solve that this equals to that. This is the interval that they told us is the Chebyshev interval. To find k, we will solve by saying these two are the same. Or we can solve by saying that this is the same. So to do that we do 0.25 minus 0.02k is equal to 0.2. So we can say again that 0.25 minus 0.2 is equal to 0.02k. This is 0.05 is equal to 0.0. So what is k here? What is k? You can multiply top and bottom by 100. It will give you 5 over 2. And what is 5 over 2? 2.5. If you do the same here, you are still going to get. So k equals to 2.5. So this will be 1 minus 1 over 2.5 squared. 2.5 squared is like 6.25. Check that. Anybody has an answer? For now, if you are laptop, you can Google scientific calculator and you will find one. Practice working in class. That's the best way to alert your brain for understanding. That's how brain works. If you just sit down like this, the brain is also going to go like that. And then you will feel like I wasted a precious 1 hour in this class. It's your choice, okay? So get active. Think about what we are doing. Question yourself. And if you don't know what we are doing, just alert me. Tell me I don't really know what you are talking about. And then I will explain it again. It's more important for you to get the meaning of all those than even to get your homework right. If you understand those concepts, because those are things you will use all your life. These statistics, you don't have the chance to do it a lot in life. So what we are learning now are things that we will use in the future, not just to pass this class. So those are the type of questions you may have about the Chebyshev theorem. Section 3.3, percentiles, box and whisker plots. Percentiles divide data values into 100 equal parts, but this is the way I will define it. I don't know how I defined it here. Yes, this is a good definition. So percentiles, the percentiles now of a value x is the proportion of values that are less than or equal the proportion of values that are less than or equal to x is called the percentile of x, or the percentile rank of x. We will say, for example, the percentiles of x is 80%, or x is the 80th percentile. So we can say it in terms of rank or in terms of proportion. So we said that the median was the middle of the distribution. So the median corresponds to the 50th percentile. When you are at the median, 50% of values are less than the median, 50% are above the median. The quartiles will subdivide data values into 4. I will start by, on the PowerPoint, it is written like really technically, but sometimes I like to explain it as simple as what it is. So we will start with note that the first quartile, Q1 is the first quartile, is equal to the 25th. Q2 is the second quartile, equal to the 50th percentile. And Q3 is the third quartile, equal to the 75th percentile. So another way to understand this thing is to start with the second quarter. The second quarter is the median. The second quarter is the median. The first quarter is the median of the lower values. The median divides data into two, lower data and upper. Let's put it that way. So once you get the median, you go to the lower part and find the median of those values. For that reason, I usually call Q1 the lower median. It's not written here like that. Okay, it's still like the median of the lower half of the data. And Q3 is the median of the upper half of the data. So sometimes we call Q1 the lower median and Q3 the upper median. And the interquartile range is a very useful measure of dispersion. Another way of measuring variance is the interquartile range. The interquartile range, IQR, equals to Q3. The interquartile range is very useful to determine some type of values that are called outliers, generally very large values or very small values. So let's do this example. Find the first, second, and third quarters of the following values representing the number of children of 15 adults in a family meeting. So we have the data values. We will arrange it in order. So from these values, I want the data to be on the same line, so we can all see. So if we have our data values like this, we know there are 15 of them. How do we find the median? Anybody remember? How do we find the median? What will be the position of the median if there are 15 values? N plus 1 divided by 2, because they are odd values. So what is the position? The position rank of the median is what? Pardon? The position. N plus 1 over 2 give us that position. We will get to 4. What is the position rank? Is it the first, the second, the third? What will be the rank of the median? Somebody else, please. What will be the position rank for the median? Yes? The 8th value is the position rank. So we now count 1, 2, 3, 4, 5, 6, 7, 8. This is the median. So we can see that 1, 2, 3, 4, 5, 6, 7, and here 1, 2, 3, 4, 5, 6, 7. We have divided the data into 2 equal parts. So the median is 4. Q2 is 4. As Q2 is 4, I go now to the lower part of the values. When I'm sitting, I will not cover. I go now to the lower part of the values here, and I find the median of this lower part. What is the position rank for that? It is, should it be 4? There are 8 values. We do n plus 1 over 2. You are close to it, but not 4. What should it be? Try again. The position rank, there are 8 values. We do 8 plus 1 over 2. What is 8 plus 1 divided by 2? What is 8 plus 1? 9. When you know something, say it. Your brain will be excited. That's how it works. I'm telling you, it's true. When you know and you don't say, your brain closes itself, and as we move, sometimes you will even become nervous. Okay, so if you want to really understand mathematics, like statistics, learn to speak out. That's why God gave us so many things: mouth, ears, eyes. You know, He could just give one. It's when all of them work together, this is the function of the brain. That is why we are doing face-to-face now. Because when you are online, you are limited in your perceptions of things. So use it, use the mouth, speak, okay? And then it engages you into the learning process. So sometimes I ask you very simple questions because I want to engage you. So what is 8% of 4.5? That means we are going to go midway between the 4th and the 5th value to find the median of the first. Is it 8? I think, yeah, the problem is me. You see, the problem is me, and everybody is sitting down quiet. I would have been a good president for the United States. Even when I'm wrong, everybody just feels, yeah, go ahead, you're right. Unfortunately, I cannot. Okay, so we have 7 values, not 8. My mistake was because of the first 8 for that rank. It remained in my brain. So I can be wrong. So don't feel shy to be wrong, okay? We are all here to learn. I am spending all this time because I know we are still going slowly. We are going to finish what we have. And there will be a time, there will be no time to be talking because we will have a little more. So if you get engaged, there will be no moment you will feel like this class is hard. If you are not, there will be a time you will feel like, I don't even know what all this is about. And it will add to it nervousness. And when nervousness gets to it, you lose control. You are no more in charge of your learning process. So we have 7. And when we have 7 values, because it's an odd number, we do 7 plus 1 over 2. And what do we get? 4. So the fourth value the median of the lower part. Q1 equals to 3, Q2, and then we do the same, 1, 2, 3, 4. This is the median of the lower part. We know how to find Q1, Q2, Q3. And the interquartile range is Q3 minus Q1. So what is the use of the interquartile range? It helps us to determine extremely low and extremely large values. Those values are called outliers. The lower outliers are less than Q1 minus 1.5 times IQR, and the upper outliers are values that are above Q3 plus 1.5 times the IQR. Remember, our IQR here is what? 2. (1.5 times 2 equals to 3. Then we look at Q1. Q1 was 3. Then Q1 minus 1.5 IQR equals to 3 minus 3 equals to 0. But we are saying that if there was a value less than 0, it will be considered an outlier compared to the data set. Now we look at Q3, well, we have 5. Q3 plus 1.5 IQR will be 5 plus 3 equals to 8. Any value that is bigger than 8, there is no value bigger than 8. But observe something here. If I have changed this 8 to like 10, do you think it will change any of the information we have? If this value change, even to 20, will it change the value of the median? Because the median is the position value. So extreme values does not affect the median. It's robust, it's very solid. You don't change it by changing the extreme values. That's why it's useful in like median income, median house cost, certain things that the variation is very high because there could be extreme values. So if we had 9 here, it will be considered an outlier because it will be bigger than Q3 plus 1.5 IQ. So we have learned here about 3 types of values: first, second, and third quarter. Another 2 values that we add to this are the minimum and the maximum. So the 5 number summaries. I'll ask you what are the 5 number summaries. Is the minimum, that is the lowest data value, Q1, Q2, Q3, and then the maximum. When you have those values, you can use them to make what we call a box Whisker. This one is not very useful for the box. Anyway, it could be. It could be. 1, 2. This is a vertical box I want to make. We can also make a horizontal box. I don't want to make both at the same time, so we shouldn't mix things up. You choose either to make it horizontal or vertical. If it was horizontal, we put 1, 2, 3, 4, 6. So what is the minimum data value for the set of data we had? I want to use that example. What was the lowest data value? Lowest data value. So I'll put a point here to start. And then what is Q1? Q2? And Q3? I'm trying my best to make a straight line. So this is Q1. This is what we will call the box misspot. I just use this data to do it. We can also use Excel to make that if you are asked to do that. I don't know why it's doing this. I want to use Excel. I want to enter data in A1. So I'm having some trouble using my laptop. Okay. I have 2, 2, 2, 3, 3, 4, 4, 4. Okay, there was. So this is my data value. I don't know what Excel you have. If you highlight it, this is The laptop is getting old. Okay, so look at your Excel. Up here, you might see, tell me what to do or something like that. If you just go there, you see something like this on your laptop. Yeah. Click there and just write box, try to write box and whisker or box plot. And then you will see a box plot coming up. Yeah. Yes, you can do that too. It's because I did something, mine is not opening large enough, so I just used that option. So you can still go to my chart. You see, mine is so squeezed here. I don't know what I did for it to do that. This happened when I am doing Zoom at the same time. So, like here? Like here?
Yeah, the number 6 on the Excel.
On Excel?
Go
this is Excel.
To the 6, where it says
Here?
Yeah. Go to the left.
Right there. Okay.
Move that either way.
Nobody, thank you. Then we can see clearly where each of, so this is a box plot, actually. It's not difficult to use Excel to do that. So if you were doing your project or your homework and I asked you to make a box plot, just do this. Highlight, go to insert chart or go to, if you want to go fast, you just go to that, tell me what to do. And you will see chart, choose the one you want. Okay. Yeah. Yeah, I'm back to this. So what we were trying to do is to use the Python and use Excel to do it. I was trying to show you how to use Excel to do it. And we can analyze. Oh, we are done. So we can analyze a box by identifying the position of this Q2. It looks like Q2 is at the middle here because it was really a simple data set, but it is not always. So if Q2 is at the lower level, we will say that the data is skewed to the right. If Q2 is at a lower level, that means more value are lower. That lower means closer to Q1, closer to the left. So that's why I like the horizontal box. It is easier to explain with the horizontal box. You can have Q1. So if you have a box like this, then you will say that the distribution is skewed to the right. Q2 is to the left, meaning that it drags more values to the left. So it is Q. Remember the description of Q, not much value. If it moves to the right, the distribution is skewed to the left. That is written. Yeah, this is it. If Q2 is at the left of the box, the distribution is skewed to the right. And if Q2 is to the right of the box, the distribution is skewed to the left. So we are done with chapter 3. As I say, we have done the main part already last week. I advise you to do your homework. What is left is not much homework. You can do your take-home problem, and it will be due on, just take it that it's due on Monday. So if you forget on Monday, make sure you finish before class, because on Tuesday, we are going to review all the take-home problems before we start chapter 4. Or should we review take-home problem 1 now? Have you seen the answers to take-home problem 1? I don't think there is much to say there. So let's assume that the 15 minutes is for take-home problem 1. If you have questions about it, let me know. We can come back on it on Tuesday. I want to say that we have completed our time by assuming that we did take-home problem 1. If you want to have question about it, you can stay and ask me, but I don't want to hold us here. I feel like I put the answer there and there is no much to explain. We will go on take-home problem 2 and take-home problem 3 on Tuesday. If I already give you the answer of take-home problem, you don't ask me that you want to submit it. I don't know how to ask you to submit when I've already given you the right answer. Okay, so please submit before 12:15 on Tuesday, but make sure you do it. And if you have questions, just send me an email tomorrow, 3 to 4, Monday, 3 to 4, Tuesday, 12:15 to 1:15. Actually, you should submit before 12:15. I was saying 1:15, not 12:15, 1:15, before this class. Do we get what I'm saying? I mixed it up a little bit. I'm going to fix it on Canvas if it is not. I want us to all submit it before class so that I go over it during class. And if you have questions before class, come to my office or send me an email so that we meet in Zoom and I'll explain what you cannot do. Yes. It doesn't say what? I was writing the correction, probably I didn't see. But if you want to do the correct one, you go to body. And you answer. So when you go to module, you see answer to take. Help sanitize before you leave, please.